Hi, so in this video I will explain you that how you can fit a support vector machines model, which is also known as SVM in short. You would require the library E1071 to use the function for support vector machines. So let's import this two libraries, then set the seed and import the data set, convert the categorical into factor variables, divide the data set into training and testing data set. All these things we have already discussed before. So now the main thing comes, which is fitting the support vector machine model. So we use the function SVM. We have already discussed the models, which is decision tree. For decision tree we use the function rpart. For random forest we use the function random forest, and for support vector machine we use the function SVM in small letters. So in R everything is case sensitive, so you need to take the care of case. So SVM, you write the syntax like this. I am right now just taking two variables, which is LWT and BWT. You can choose any other variables as well, but there are 9 variables. I'm just taking these two variables and predicting the low variable, taking the data frame train df to on which the data model will learn, and the kernel is linear. So we are trying to fit a support vector machine with linear kernel. So I will explain what are these, because it includes a lot of technicalities and mathematical discussions involved in support vector machines. So that is another big lecture on how all this works. But just to know how we can fit this model in R, we have this lecture. So on this kernel, there are a lot of kernels you have radial kernel as well. So if you want to know what are the arguments you can give into SVM, you just write question and just hit Control Enter. On the right hand side you will get all the arguments which you can fit. To use all the arguments you need to read a lot to understand about all the mathematical details, how the support vector machines work and what are the kernels being used and all those things. So I will discuss about in general that what is it. Actually it tries to find a line which separates the data points, and that plane is at the farthest distance from each of these two classes. So I will actually plot that data points in 2 dimension, and then we will try to fit a line in between, so that on the one side there is a class with the low is equal to 0, on the other side there is a class with low is equal to 1. So let's not go into the mathematical details right now, but let's fit the kernel and linear, and the type is equal to C classification, which is saying that we want to do classification using the support vector machines. So let's go back. We are here, so let's select this, hit Control Enter. So summary is this. It's saying support vectors, number of support vectors is 26, and it is saying classification we want to do. Kernel uses linear. We have parameters like cost and gamma, which you can tune. You can choose to change the cost and gamma, and you can also change the kernel to linear, polynomial, radial. You can choose the cost to be 0.5, 0.6, and see that which of these are parameters are best for your data and having good predictions for your testing data set. So most important thing is getting the good predictions on the unknown data set, which is the testing data set. These parameters are needed to be optimized in such a way that they give good predictions on the unknown data set. So once we have fitted, let's do the predictions as before. We see the confusion matrix. It is perfectly doing predictions, and we have 26 observations predicted as 0, and actual is also 0. We have 12 observations predicted as 1, and actual is also 1. So we have around 100% accuracy. So that is, if you see, it's saying accuracy is 1, that means 100% accuracy. Actually there is a reason why I chose in SVM, while fitting SVM, why I chose the BWT. I already explained you that in this data set BWT is a very important variable which can predict the low with 100% determination. It is very deterministic, so it can it is 100% determined to predict low variable. It is, so it has no confusion in predicting the low variable, because BWT there is a clear separation between the low is equal to 0 and low is equal to 1 on the basis of just the BWT, which we have already seen in the case when we were discussing about the decision tree. So that's why we were not using, but right now we just try to see that can we plot LWT and BWT and see that can we have the separation. So let's see how our data looks like. So let's plot the testing data set. Let's plot these two variables which we have taken. We have taken LWT. Now let's plot BWT, and let's see what happens. We see that on the right hand side this data looks like. So LWT on the right hand x-axis, and on the y-axis we have BWT. We have the data points. So we want to see which of these are low and which of these are low is equal to 0 and which of these are low is equal to 1. We want to find. So let's color them by the actual low values. Let's see what it looks like. Right now these are, and the dots are not filled. Let's fill them. So solid dots. For that we will use PCH is equal to 19. It is actually different shapes, so I am using 19 for using the solid dots. Let's see how it looks like. Now you see we have solid dots, and we have red observations being low is equal to 0 and black observations low is equal to 1. These are actual data, and we have fitted the support vector machines model. What the support vector machine will try to do is it will try to find a line like this in between, like this, which goes something in between like this, which tries to separate this cluster of data with this cluster. So this line, it will try to find the best line which is at the farthest distance from both of the sides, from this cluster and from this cluster. This is in very general, very layman language I am trying to explain, so that you get an intuition of what is support vector machines. So once again it's trying to find the best line in between, which is at the farthest distance from this cluster and this. So the line you can create, you can also find a line which is nearby this. You can also find a line which is nearby this cluster, but we won't be considering those, because the optimization of support vector machines will find the best line which is in between and which is farthest from both the sides. So this is the plot. Now see, if we want to see the actual data, but we want to see the coloring of this data on the basis of predictions. So we have predicted, we have the prediction with class. So let's see how the plot looks like. We can see the predictions are also the same. The coloring of the actual values of low and the prediction values are the same. The plot is looking the same as the actual data. That's why we see the accuracy was 100%. So you just need to keep in mind, for fitting a support vector machine you need to use the SVM, and in order to use the, you can choose to tune the parameters like kernel, arguments kernel, gamma and cost, which is trying to fit a different kind of hyperplanes. It is actually trying to different hyperplanes, and it will try to find in different space, because some data is linearly separable where you can separate by line, but some data is not linearly separable. Some data is separate, you can only separate by a curve. So in that case we might require polynomial kernel, or we might require radial kernel. And then you have the parameters cost and gamma, which are used in all these optimizations of support vector machines. So thanks for watching this video.